the National Weather Service Central Region Headquarters. Doug Cluck and John Ives had asked me to step in here today to help facilitate this call since they're both unavailable. So we'll zoom right ahead here, and I'd like to introduce the two speakers that we will have here today. First up will be Dr. Stuart Foster. He is the state climatologist for the state of Kentucky. And then secondly, we will have Brad Rippey, who is a meteorologist with the USDA Office of the Chief Economist. So Dr. Foster will be starting it off for us, so whenever you're ready to go right ahead.
All right, thanks very much, Jennifer, and welcome everyone to today's webinar. There's some general information I'd like to pass along. You've probably seen this before on some of the calls, but this Drought and Climate Outlook webinar is a collective effort of the following folks there. And again, you can see Doug Cluck and John Ives with NOAA, the state climatologist, the Midwest and High Plains Regional Climate Centers, NOAA's Climate Prediction Center, Iowa State University, and the National Drought Mitigation Center. And as you do your planning for the next month, the call in October will be on the 17th at 1 p.m., and Dr. Jim Angel, state climatologist of Illinois, will be hosting that call. You can register for that webinar today at the link provided there, and also access past webinars on the Midwestern Regional Climate Center and High Plains Regional Climate Center websites. And as noted, you'll have operator assistance at the end of the presentation if you have questions. I will start out by very briefly highlighting a couple recent events that have occurred since the last webinar, and then go into current conditions in terms of the drought situation and looking at the recent change over the last 30 days or so that lead to those conditions, and then place them in a historical perspective so that we can really understand how things fit into the bigger picture. And then we'll lead into the updated outlooks that were just released today in terms of monthly seasonal outlooks for climate and drought. Okay, recent events over the last month, noteworthy heat wave in the Midwest. Certainly after a very cool summer, we've ended up the situation with warmer than normal temperatures, high temperatures ranging about 6 degrees above average, nighttime lows as much as 11 degrees above average over much of the central plains and Midwest. And in addition, the more recent event that has certainly been on the news across the country, as we're concerned about the folks in Colorado that have dealt with the tremendous flood situation in that area. You see a map there with total precipitation amounts over a week of about 17 inches or as much as 17 inches in some areas. The drought monitor for this week, again issued a little bit earlier today, shows the continuation of drought in much of the central plains and western plains, and highlighting the return and intensification of drought conditions in portions of the Midwest. Looking back at the last 30 days, you can see, again, the heat wave, part of a broader pattern of above normal temperatures, again, representing a change from what we'd seen earlier in this summer. So we've had much of the Midwest and upper and Great Plains running 3, 4, as much as 8 degrees above normal or above mean temperature since August 20th. Meanwhile, precipitation patterns, we can see there the eastern portion of the Midwest has been particularly dry. Bullseye is kind of highlighted there from Missouri up through Iowa into Minnesota, whereas the northern plains and the Dakotas, part of a little bit of South Dakota and much of North Dakota, going into Montana, Wyoming, Colorado, and a bit of Kansas being wetter, a little bit wetter than normal, though not appreciably so. This is a map from the National Drought Mitigation Center. For those of you that are very familiar with the drought monitor maps, this shows the change in the classification of areas over the last month. So the areas that have a little bit of greenish tint to them represent parts of the country that have seen some improvement of at least one, if not two classes or more in terms of drought status. And again, that's consistent with areas that have been receiving more precipitation over that 30-day period. And in contrast to that, we have areas in the brown shading where drought conditions have deteriorated. We're getting drier, and again, that's focused on portions of the Midwest. And that's certainly a concern moving forward. The 7-day stream flows, all in all, look pretty healthy for the area, certainly well above normal in areas of the western plains where we've seen that precipitation, and again, some cases, record levels of precipitation. As we move back eastward through the Midwest, while we're getting dry, and there are some areas where stream flows have dropped below normal for this time of year, certainly the largest number of sample locations are representing stream flows that are in the normal range, and in fact a few areas that are slightly above normal. So stream flows are not indicating widespread problems at this point. Okay. The next map shows current soil moisture anomalies, and again highlighting what we've seen on the previous slides, that we have an area in the Midwest that is drying, and that drying is intensifying and is occurring very rapidly. Soil moisture here is certainly an issue from a couple of concerns. Main one here probably on the agricultural side in terms of influence of soil moisture on weather patterns. We're getting into the time of year where it's not coupled quite as much with our precipitation schemes and so forth, but nonetheless is still noteworthy. Now we'll go through some slides where we look back over the historical perspective a little bit more, start to go back, and in looking at the drought development, of course, we're all aware that last year we were in very intense drought situation, and looking at record low flows and concerns about that on the Mississippi River system in various areas. And then we know that we saw a lot of change in that very, very quickly. The map on the left shows precipitation as a percentage of the mean from April 1st through June 30th. So that 3-month period, and I'm going to refer to that 3-month period repeatedly here. So take a close look at that map. It shows areas in the Midwest and the northern plains being much above average in terms of precipitation, while areas that were in drought in the central plains and part of the western plains running a little bit below mean in terms of precipitation. We look at it on a percentage basis. And then as we look on the right side, we're looking at the 1st of July through almost 3 months, through September. So July, August, much of September. And we see a very, very different pattern developing here. So we see the very dry conditions developing in the Midwest and the wetter conditions in the central and western plains. And corresponding to that, again, another map from the National Drought Mitigation Center that shows the change in drought status or class of drought over a 3-month period. The pattern qualitatively is very similar to what you saw on the 1-month period, but the magnitude of it has increased. We're looking at it over a longer period of time. Again, the message here is clear, very rapid and intensifying dryness in the Midwest, and some relief as we move farther out in the plains. Okay. Now we're going to spend a little bit of time with a series of graphs designed to give you some broader historical perspective. And I need to take a moment to get you up to speed so you know exactly what you're looking at. First of all, start in the lower right corner and you see a reference map of the traditional U.S. climate divisions. And you can see the state outlines there. I've highlighted 6 groupings of climate divisions selected to try to represent areas that were in higher or more severe levels of drought and some areas that were not, and providing some coverage over much of the cropping region of the Midwest and plain states. So you can see from the lower left there, Colorado and Kansas, there's a pair of climate divisions there. you've got a pair of climate divisions in Nebraska. You move north of there, you've got a climate division in southern North Dakota and one in northern South Dakota. Then you come farther east and you've got a couple divisions identified in Iowa. And move a little north, there's a climate division in the eastern part of Minnesota and west central part of Wisconsin. And then we come farther east and pick up a climate division in Illinois and Indiana. So we're just trying to get an idea on a little bit more focused level of what the precipitation situation has been this year, and try to get some sense of what climatology tells us about the predictability of the future drought conditions. So the graph on the left is broken into 6 groups or 6 boxes there, corresponding to the groups of climate divisions. So on the left, you see on the horizontal axis, Colorado 03 and Kansas 01, the climate divisions that are corresponded there on the map. And you can see the others moving across the bottom and locate those on the map. The vertical axis shows precipitation in inches. And what we are looking at in terms of the blue bars looks a lot like a barcode that you might find on a packaging label. Each one of those bars represents cumulative precipitation for the April through June period, that 3-month period from 1895 through 2013. So you've got 119 years worth of data, and the red pin that slides in there shows the 2013 cumulative precipitation total for April through June. And so you can look at where 2013 falls relative to the historical distribution of precipitation over that time of year, again going back to 1895. As you look across that graph, what you'll note is that the Colorado-Kansas area, the farther west in the plains, was unusually dry during the April through June period, again following up a drought year last year. But as you come east, as you get into Nebraska, those locations as we got into April through June were near normal to slightly above normal precipitation. And then as you move farther east, certainly when you get to Iowa, the Minnesota, Wisconsin, Illinois, Indiana, the distributions reflect that those areas expect more precipitation traditionally. But you'll also notice as you look at the red pins sliding into the distribution that those areas have generally been wetter than normal, and in some cases near or at record levels for April through June. So the Central Climate Division in Iowa, for example, with about 23 inches is second all-time since 1895 this year for April through June, while the West Central Climate Division in Wisconsin recorded a record level of precipitation for that period. Now we're going to move and take a look at the same graph, but we're going to look at it not for April through June, but following that we're going to look at July and August, because that's when the pattern started to change. So there you can see now as we look across from the left, precipitation amounts in Colorado and Kansas and those areas approaching normal to a little bit below normal. Nebraska, about normal, a little bit above, a little bit below, depending on where you are. But as you move farther east, the same areas that were unusually or at record levels for precipitation totals are now near record low totals. And indeed, the Climate Division in Wisconsin transitioned from a record high precipitation total to a record low precipitation total in the switch from April through June and then going July through August. Now, another set of graphs that will provide us some perspective on the persistence of wetness or dryness in some of these climate divisions historically, and then as a guide to predicting future conditions here through September and October, through the remainder of September and October. So you're looking at a scatter plot on the horizontal axis, if we're looking in the upper left. On the horizontal axis, you see cumulative precipitation plotted for the April through June period, again, that 3-month period. On the vertical axis, cumulative precipitation for the 2-month period, July and August. So the horizontal axis represents before, the vertical axis represents after. The points on the plot are shown with the labels for the individual years. So you can see, as an example, in the Northwest Climate Division of Kansas, in the upper left, there's the 1993 year of record flooding on the Mississippi system. And so not surprisingly, you see a very, very high precipitation total particularly for the period July through August. Okay, the lines on the graph in the middle, the vertical line is the median precipitation historically for the April through June period. So all of the years that plot to the right of that line were wetter than average. All the years that plot to the left of that line were drier than average. Likewise, the horizontal line, all of the years that plot below the horizontal line were drier than average for the July through August period. The years that plot above were wetter than average for the July and August period. So in this location, again, we saw that Colorado, the western part of the plains, were dry coming in, and they really didn't see the same precipitation totals that we saw in the east. So those locations stayed in the lower left corner. You can see 2013 plotted in the lower left. As you move to the right graph, that's showing the same structure, but now on the horizontal axis, we're plotting cumulative precipitation for the July-August period, and then we're looking at how that might predict precipitation for the following September and October period. So here, the year 2013 is shown as a vertical red line as opposed to a dot on the map because we don't know what the September and October precipitation total will be. We simply know that it will plot somewhere on that vertical red line, and we'll know the answer to that following October. What you want to take a look at there is the notion that, okay, in the vicinity of that red line, that is, for years when we had somewhere around 4 inches of precipitation for July and August, years that are similar to this year, the following September and October produced anywhere from about 1/2 inch of precipitation to about 4.5 inches of precipitation. And in the case of 1946, almost 10 inches of precipitation. The bottom line, a relatively dry period for July and August does not give a clear indication of whether September and October tend to be wetter or drier than average. So the persistence of the pattern of precipitation does not show a strong signal there. Okay. The next graph is a similar one. I won't spend as much time with this, but this is looking at Iowa in the South Central Climate Division. In the upper left, in this case, you see the year 2013 plotted in the lower right quadrant, indicating, again, that it was very wet during the April through June period, and then became very dry in the July through August period. And it was a very unusual year as such. You can see very few other years that were located in an extreme location in that portion of the graph. In the lower right, again, we can plot with a line, a vertical line, the precipitation total that was recorded for July through August this year, but we don't know where the September and October precipitation total will plot on that line yet. But if we simply follow that line upward, we see that in other years when we were very dry in July and August, 1953 was a drought year where it continued to be very dry through September and October. However, we have several years then, including 1983, 1934, 1914, where we went from very dry conditions to very moist conditions. So again, there's a very, very weak signal, if any, as to what the current conditions indicate about future conditions over the next couple months. And the last graph, again, highlights the West Central Climate Division in Wisconsin and you see 2013 standing out in the lower right quadrant of the graph in the upper left portion of your plot or your page. And truly, 2013 stands out as a remarkable outlier for being record wetness in April through June, and then record dry conditions in July and August. And not just by a little bit. It's out there, the true definition of an outlier. You see the 2013 total plotted in the lower right graph, representing a little over 2 inches of precipitation for that period. And then as you look across that graph to the right, you see that traditionally there is essentially no visibility at all based on climatology as whether dry conditions in the July through August period might predict effectively September or October precipitation. It appears to be almost just as likely to be very wet as it is very dry. So very limited visibility based on climatology for areas throughout the region. The next graph is a set of box plots that show the climatology for monthly precipitation totals based on the 1981 to 2010 period. You can see the tendency through almost the entire region that the spring months, once you get into May, June, July, those are the wetter times of the year, and as we get into October, November, December, it tends to get into the drier portion of the year, and that continues through the winter months. The exception to that is as we get down toward Illinois and Indiana, we don't have as much extreme variation. We have precipitation that's distributed a little more evenly throughout the year. The area inside the blue shaded part of the box indicates that 50% of the years had precipitation totals within that range, and the whiskers extending above and below go to the maximum and minimum values observed over that 30-year period. So the takeaway here, other than just giving you an idea of the precipitation climatology and how it varies throughout the region, is that as we look at projections that tell us whether we might be above or below normal on precipitation or what those expectations might be, as we look at these graphs here, we see that regardless of whether we're above or below normal, we tend not to get very much precipitation during the fall and into the winter months. So any outlooks need to be conditioned by the fact that we simply don't expect much precipitation anyway. Okay. Moving to outlooks then, the INSO outlook, this graph shows a progression of 3-month periods from August, September, October, November, and so forth. And each 3-month period is represented by a set of 3 bars grouped together. The blue bar representing La Nina conditions, the green bar neutral conditions, and the red bar El Nino conditions. The vertical axis shows the probability of conditions occurring within that class based on the current forecast. So we're in a neutral phase. You see the green bars dominate. They get a little bit lower as we go farther out. The takeaway is that INSO is in neutral phase. We have a strong expectation that it's going to continue in that neutral phase over the foreseeable future. Now the outlooks from the Climate Prediction Center, the 8 to 14 day temperature outlook showing a persistence of these warm temperatures that we'd seen over the last month throughout much of the eastern 2/3 of the country. Meanwhile, precipitation possibilities of being above normal precipitation across the northern plains and part of the northern Midwest. So a slightly elevated chance of above normal precipitation in the 8 to 14 day outlook that goes from September 26th through October 2nd. The climate outlook for the month of October again shows a persistence of above normal temperature expectation across much of the plains and the Midwest. The signal regarding precipitation is much weaker. There's a small region centered on Nebraska and Kansas, where there's a slightly elevated probability of below normal precipitation. Otherwise, equal chances. The models simply are not giving a clear signal of what to expect, implying that we would fall back on climatology. And we've just seen in some of the recent slides what that climatology looks like. Okay. Here's the 3-month outlook going from October through December. And again, not a major change in the pattern. We've got, again, a small area of above normal precipitation anticipated. That location of that has shifted up into the northwestern plains and Montana and Idaho. And temperature, the area of above normal is backed off to a greater coverage of equal chances. So again, without a strong INSO signal, we don't have clear indications of what we might anticipate in terms of climate. We fall back on climatology. Okay. The seasonal drought outlook shows, as we might expect from what we just looked at, expectation that areas of drought are likely to persist. There is the possibility of improvement occurring in some areas that are in the periphery of the Midwest and Great Plains region. Summarizing, recent conditions, we've seen dryness in the Midwest rapidly intensifying, wetness in portions of the Great Plains, easing drought conditions in limited areas, but certainly not eliminating them by any means. The outlook in terms of climatology, looking at the graphs that we reviewed, we can conclude that the recent past is a poor indicator, a poor predictor of the near future. So the fact that it's been dry lately does not necessarily indicate that it's going to continue to be so. It doesn't give us much of a signal in any direction. Upcoming fall and winter months traditionally are relatively dry, so even if we're above normal precipitation, we don't expect a tremendous amount of recharge into those dry areas. Nonetheless, with evapotranspiration reduced as we get into the cool period of the year and past the growing season, that precipitation, whatever falls, is very critical for recharging groundwater and soil moisture. The outlook in terms of models, again, INSO expected to remain in neutral phase. Climate outlooks providing minimal guidance beyond simple climatology, and drought conditions expected to persist through the end of the year with improvement on a small scale in some areas. For further information, you can go to a number of websites here and allow you to browse through those at your leisure if you look at the recorded version of this. If you have questions, there's my contact information along with a number of other folks who have supplied information for this webinar. And with that, Jennifer, I'll turn it back to you.
Okay, thank you very much, Dr. Foster, and everyone on the line. If you could please hold those questions until the very end. Next, we'll go ahead and turn it over to Brad. Are you ready to take it over here?
I'm ready to go as soon as I have keyboard control.
All right, I'm just passing it over to you.
All right.
Should have a window that popped up. There you go. I see your screen.
All right. I am not seeing my screen right now. Let me see.
I just see the Windows logo.
I've got everything but the presentation screen right here. So I am a little puzzled as to what's going on. Sorry about that.
No problem.
Huh. I'm not sure where to go from here.
Icon on the bottom on the left there, is that the PowerPoint? Keep going. There, try clicking that one.
This one? No.
You may have to reopen your PowerPoint. Okay, I see your presentation.
All right, are we good?
Yep, we're good.
All right, sorry about that. Slight delay. I'm going to take us into the agricultural arena here and pretty much stick to talking about the agricultural situation, past, present, and maybe a little bit of future here for the 2013 growing season, and of course specific to the National Weather Service Central Region. I'm going to start off with the same slide that Dr. Foster showed, and that is the latest U.S. drought monitor. And with the focus on the central region there, you can see that we have seen resurgent drought, short-term drought, primarily affecting a good chunk of the Corn Belt. And as you head further to the west, that drought is increasingly long-term, and of course, as you head into Colorado and western Kansas, we've seen scads of rain recently. So in any areas there in the far western part of the central region that there is any drought, it's strictly long-term drought at this point. I'm going to start off looking at a few commodities and start with the big one, corn. And this chart is based on crop production data from 2006 to 10 and overlaid with the latest U.S. drought monitor information, so it's valid as of this morning. And it does show that approximately 55% of the U.S. corn production area is within an area experiencing drought at this time. And that, if you look at a state-by-state basis, I put asterisks on the central region states so you can kind of focus in there. And so, for example, in Minnesota, which is the number 4 U.S. corn production state, 92% of the corn grown in Minnesota at this time is in an area considered to be in drought based on the U.S. drought monitor. And so, obviously, the central region is huge. And when it comes to corn production, 13 of the 14 central region states, all but Wyoming, are considered major corn producers. And about 85% or so of the U.S. corn traditionally comes from the National Weather Service central region. Now, if you look at a time trace, corn areas in drought, we bottomed out at only 17% of the U.S. corn production area in drought back in July, but we've really ramped up just the last few weeks to that aforementioned number of 55%. Now, looking at the U.S. corn conditions and focusing on the bad at this point, you'll notice that 3 states in the central region among the real big producers are bordering the Mississippi that are kind of suffering more than anybody else. Those being Missouri, Iowa, and Wisconsin, all at 28% of their corn rated very poor to poor. As you get on the fringe of the Corn Belt, we see some slightly worse conditions in Kansas and in Colorado. But from the big state, the big producer states, you're really focusing in on again, Missouri, Iowa, and Wisconsin. Doing a lot better as you head east and west of the Mississippi. Upper Midwest not doing as bad. Doing better in the eastern part of the Corn Belt as well. Nationally, 18% of the U.S. corn rated very poor to poor, a far cry from last year at this time when we were looking at 50%, as you can see in the lower left corner. Now, we have been dealing with the situation of a very late planted and late developing crop, so we continue to keep an eye on the frost and freeze situation. We've been teased with a little bit of frost activity in the last week or so across the far northernmost production areas, but not enough to be a concern. We're going to have another close call coming up this weekend with another cool air mass coming in, and certainly the potential for frost from the Dakotas eastward into Michigan coming up this weekend. At this time, it does not look like temperatures will be low enough to cause significant concern for immature corn. But it is worth noting that in some of the northern production states, especially Minnesota, only 5% of the corn fully mature by mid-September, and that compares to the 5-year average number of 28% for that state. So again, a lot of those states bordering the Mississippi that were so late planted and had a cool summer, we are dealing with maturity issues for the corn. Now, looking at corn condition over the last 5 years, we've seen kind of a troubling trend. Starting with the perfect year, we'll call it, 2009, we had a record high 164.7 bushel per acre crop that year, and it's been all downhill from there. 2010, 11, and then at the bottom in purple, the crop conditions for 2012. And then come to 2013, we're kind of on a parallel with 2011, which was not a very good year for corn production in the U.S. We ended up at 147.2. Just last Thursday, the latest number from the field survey from USDA NASS indicated that we're expecting a 2013 crop averaging 155.3 bushels per acre, which would be a lot better than last year, obviously, but still not very good compared to what some of the expectations were early in the season. Here's last year, 2012, month-by-month forecasts, And it does show that the initial expectations were for a crop of 166 bushels per acre early in the year. That ended up being down in the 123.4. A lot of the damage was done early last year. This year, the crop was so late in maturing that when the field survey came in for August, it came in pretty low, a little above 154, and actually bounced back a little in September. That may have been because the kernels just weren't big enough to send off to the lab to make a good crop estimate by August 1st in 2013. So a little bounce back in September based on that late maturity. I'm going to go through soybeans and a couple other commodities here, so I'll go a little quicker through this. First, for the soybean areas, 45% of the U.S. production area currently in drought as of this morning's U.S. Drought Monitor. And if you look at the individual states, again, the central region states highlighted, 12 of the 14 central region states considered major production states, all but Wyoming and Colorado considered here. And we've got pretty rough conditions, again, in some of the states bordering the Mississippi, Minnesota, 85% of the soybean area in drought. Nebraska, as you head a little bit to the west, 78%, and Iowa at 68%, kind of jumping out there among the real big production states. Soybean areas in drought, that's also come up just like corn quite a bit over the last several weeks, from a low of 8% in drought back in July when we were still looking pretty good, living off that spring moisture that Dr. Foster talked about. But recently we've really started to see some stress on the soybean crop. Soybean condition, those same three states really jump out. Missouri, Iowa, Wisconsin, all above a quarter of the crop rated very poor to poor in mid-September, as this late heat and drought have really adversely affected the soybean crop. Nationally, 18% of the crop very poor to poor. That's half of what we had this time last year. Soybeans also, although progress is all over the board, we see pretty good progress in the western production areas, the Dakotas, Nebraska, and in the far east like Indiana, but really struggling to get this soybean crop mature, especially look in Iowa, where you've only got 7% of the soybean crop dropping leaves in mid-September. 31% is the 5-year average. Soybean conditions over the last 5 years and final yields in the lower left. And you can see, just like the corn crop, 2009 was an almost perfect year, and it's been downhill since then. 2013, a bit more troubling than even corn because we've actually fallen below 2011, both on the expected yield based on the latest field survey and also below the condition that we saw in 2011. So we'll have to keep an eye on this soybean crop. There's potential that with the very late developing drought and the heat, that soybeans may have been hurt worse than corn by this 2013 resurgent drought. Last year, it was actually a little bit misleading. We had some late rains. Hurricane Isaac's remnants, for example, came through the part of the central region, and it cooled down late in the summer, and pods filled more than expected. So we ended up with a better crop than we thought in September. So there's a little rebound on that soybean crop. This year, we've been trending down, and I should have had asterisks on August and September there because those were based on field surveys. But we're down from an initial estimate of 44.5 early in the year, and now we're just we're below 42 bushels per acre. So again, apparently this soybean crop has been really hurt by the late summer drying trend and the heat. Looking quickly at hay, at this point, 39% of the domestic hay inventory is in drought. All 14 of the central region states are on the list of major hay producers, and the central region accounts for about half of the U.S. hay production. Hay in drought has also had been inching upward, but with the rains across the Great Plains recently, we saw that number come down during the most recent week, 2 percentage points. And sort of a corollary to that, pasture and range condition. I'm not going to spend much time here, but do want to point out that all the states bordering the Mississippi from Missouri northward, 20% or less of the pasture and range is currently rated good to excellent. And if you look at the flip side, very poor to poor, the big highlight is on Iowa and Wisconsin. 63% of Iowa pasture and range rated very poor to poor, 61% of Wisconsin pasture rated very poor to poor. So we've really seen a browning out of the grasses across those two states in particular. Cattle areas in drought, with the concentration of cattle across the Great Plains, the Western Corn Belt, We still see 53% of the domestic cattle inventory in drought as of September 17th. And we see for cattle, 13 of the 14 central region states are on this chart, all but Indiana. And so still a significant portion of the cattle inventory in the U.S., more than half in drought as of September 17th. And we also shaved off 2 percentage points in the last week with the heavy rains across portions of the Great Plains. And finally, back to winter wheat, since we're starting up the season there. Despite some of the rains on the plains, we still see 43% of the winter wheat production area in drought as of September 17th. And 8 of the 14 central region states are on this list. And certainly Kansas is a huge one. It outproduces every other state by a factor of 3 or more. And so we still see half of the Kansas wheat crop in drought. However, some of that has shifted to a longer-term drought. It's more of a subsoil moisture issue. We have certainly dampened the topsoils, especially across western Kansas in recent days. Winter wheat in drought, we've been on a steady downward trend on that since the end of the last growing season, but still something to watch, especially with the lingering long-term drought across some other production areas. Winter wheat planting getting underway, just underway in some of the Corn Belt areas, 1% planted in the states bordering the Ohio, and then a little bit more planted as you head into the Great Plains region, with Nebraska and Colorado 22% planted, a little behind schedule by mid-September. And I will stop there, and I think we can open it up to questions.
As a reminder, if you would like to ask a question, please press star and the number 1 on your telephone keypad. Again, that is star 1. We'll pause for a moment to compile the Q&A roster. Your first question comes from the line of Bryce Anderson.
Yes, gentlemen, thank you for your presentation this afternoon. I was wondering, in the absence of a definite ENSO signal, if you can make comments on what you see as the primary weather drivers possibly this fall. Do you have any thoughts on that you could share, please?
Bryce, this is Brad Rippey. I'll take a quick crack at that, if I may. The new outlooks from CPC came out this morning, and I found it very interesting looking, especially at the temperature patterns, that it appears that there's kind of a persistence temperature forecast for October. But if you look at the October, November, December, you'll notice that there is a revert to the summer pattern. That is warm in the west and warm in the northeast, but generally cool as you head down through the Great Plains, the Midwest, and into the southeast. So at least to me that suggests that some of the drivers that we had this summer may well return at some point, not immediately, but as we head deeper into the autumn. And so I don't know if Dr. Foster would like to comment on that, but it's something I noticed looking at the charts.
I don't really have anything to add at this point. It's just a lot of uncertainty at this point. As you mentioned, there's not a strong driver out there. So,
am I still on?
Yes.
Okay. Thank you. The reason I asked is that it seemed like in the higher latitudes this past spring, we had this tremendous round of blocking high pressure that kind of rerouted the jet stream more into the Midwest and so forth, and helped to bring about that heavy rain. Do you see a chance that could form again sometime this fall? And then that'll be my follow-up.
Yeah, Bryce, in the absence of a strong ENSO signal, you have to be concerned about blocking over the North Atlantic as being an issue. I know that looking at the NAO forecast earlier today that there is an indication that we'll be heading into a more negative NAO over the next couple of weeks. So, it's something to watch. North Atlantic blocking in the absence of ENSO can sometimes really drive weather patterns quite significantly, but it's not something obviously I don't make the forecast like CPC does, so I probably can't get too much into the forecast angle there.
Again, if you would like to ask an audio question, please press star and the number 1. And there are no further questions at this time.
Okay, if there aren't any other questions, we'll go ahead and wrap it up. I would like to thank